Hello, dear grade 10 students. Hope you are all doing well. This is Mr. Idris, physics teacher. Today's lesson, we're going to explain heat in chapter 4. As you can see here in this chapter 4, we have three sections. Section 1 about temperature and heat. Section 2, change in temperature and phase. And section 3, the relationship between heat and work. Let's get started from section 1. Okay. Guys, look, in chapter 4, section 1, we will talk about temperature and heat. So it's very important to compare between temperature and heat. This is two different things. Temperature, the definition of temperature is a measure of the average kinetic energy of atoms or molecules within a substance. The faster the particles move, the higher the temperature and vice versa. So what does temperature depend on? Temperature depends on the average kinetic energy of the atoms or molecules. More kinetic energy, more temperature. So when does the kinetic energy gets more or increases? When the particles are moving very fast. By giving energy as heat, what happens to the particles? The particles are moving very fast. So in this case, kinetic energy of the particle increases, then the temperature also increases. So what is the relation between temperature and kinetic energy? Is directly proportional. Okay, and kinetic energy with the speed of the particle also directly proportional with the square. Okay, when the speed of the particle increases by giving energy as heat, what happens to the kinetic energy? Also increases. When kinetic energy increases, what happens to the temperature? Temperature also increases. So can we say temperature depends on the average kinetic energy of the molecules? Yes. And the average kinetic energy according to this equation of the molecules is equal to 1 over 2 mv squared. Average kinetic energy is directly proportional to the square of the speed. As the speed of the particle increases, kinetic energy also increases and the temperature also increases. Uh, Thermometer, what is thermometer? Thermometer is a device that measures temperature, that can be used to measure the temperature, okay? Or the degrees of the hotness or coldness of an object. What does object's temperature depend on? Object's temperature depends on what? As I mentioned, the temperature depends on average kinetic energy of atoms and directly proportional. What is thermal equilibrium? Another definition in this section is the thermal equilibrium. What is thermal equilibrium? The state in which two bodies, two objects in physical contact with each other have identical temperature. What is thermal equilibrium? The state in which two objects, two bodies, which they have the same temperature. Okay, if two objects they have the same temperature, there will be no energy transfer between these two objects because they have the same temperature. For example, if you have a beaker of water, okay, the temperature of water, for example, 20 Celsius, and if you have a piece of metal, okay, submerged in this water, the temperature of metal also 20 Celsius. So can we say these two substances, these two different objects are thermal equilibrium? Yes, absolutely. Why? Because both of them, they have the same temperature. Okay, what is thermal equilibrium? Thermal equilibrium, the state in which two bodies in physical contact which with each other have identical temperature. So we don't have energy transfer. Energy transfer at thermal equilibrium is zero. So we have some important tips and notes about the temperature and the thermal equilibrium. Temperature is proportional to the kinetic energy of atoms or molecules. Temperature has three scales. Okay, what are the scales of temperature? We have three measurements like Celsius, Fahrenheit, and Kelvin. How many scales do we have to measure temperature? Three: Celsius, Fahrenheit, and Kelvin. But which one is the SI unit? Kelvin is the SI unit. Okay. If it brings in the exam, which of the following is the SI unit of temperature? Kelvin. Okay. So another type of this question: which of the following can be measured for temperature? All of them. But which one is the SI unit? Kelvin. Okay. Energy is transferred as heat from object with higher temperature to the object to those with the lower temperature. Okay, the energy transfer exists between two objects because of different temperature. Usually the energy transfer from the object with higher temperature to the object with the lower temperature. So the higher temperature of the object with the higher temperature loses energy as heat, and the object with the lower temperature gains or absorbs the energy as heat. Adding or moving energy usually changes the temperature. So look at this figure. Transfer of particle kinetic energy as heat. Energy is transferred as heat from the higher energy particle to the lower energy particle. So the net energy transfer is zero when thermal equilibrium is reached. When does the net energy transfer is zero? When the thermal equilibrium is reached. For example, in this figure, as you can see here, the temperature of water is 5 Celsius and the temperature of the juice 45 Celsius. How many substances do we have? 2. Water and juice. Which one has more temperature? Absolutely the juice has more temperature, 45 Celsius. Do we have energy transfer between these two objects with different temperature? Yes, absolutely. Why? Because we have difference in temperature. Which one release energy, which one lose, and which one gain? The higher temperature loses energy, the lower temperature gains. So juice release energy, loses energy, but water gains or absorb energy. After they reached what? Thermal equilibrium. At thermal equilibrium, both of them reached 11 Celsius. Now T of water is 11 Celsius and the temperature of the juice is also 11 Celsius. We don't have energy transfer anymore here. Energy transfer is equal to what? Is equal to 0. Why? Because the thermal equilibrium achieved here. After a physical contact, the two substances reaches the thermal equilibrium. At thermal equilibrium, there will be no energy transfer because both substances reaches the same temperature. At the same temperature, we don't have energy transfer, and the two objects can be stated as a thermal equilibrium. Why always energy transfer from object with higher temperature to the object with lower temperature? Look, for example, if we have a bucket of water with the temperature 10 Celsius and a piece of metal with the temperature like 50 Celsius. How many substances do we have? 2. Which one has higher temperature? The metal, 50 Celsius. If we put the metal into a bucket of water, as we put the metal into the bucket of water, do we have energy transfer? Yes. Why? Because we have difference in temperature. Which one lose and which one gains energy? The higher temperature lose. This one loses energy, okay? And this one gains. The substance that loses energy, what happened to the temperature? Temperature decreases. But the substance who has gains energy, its temperature increases. So after they reaches the equilibrium temperature. For example, assume that this is just for example, okay? Both of them reaches like maybe 15 Celsius, for example, okay? Assume, this is assume. This is not maybe correct, okay? Assume that both of them reaches 15 Celsius. After they reaches the 15 Celsius, can you say the two substances reaches the thermal equilibrium? Yes. Thermal equilibrium. No energy transfer anymore, okay? But why the object with higher temperature loses and the object with the lower temperature gains? Because the object with higher temperature has a higher kinetic energy. Has what? Higher kinetic energy. That is why the object with the high temperature loses energy. Why the object with the lower temperature gains energy? Because it has low or less kinetic energy. Okay? It has less kinetic energy or low kinetic energy. So this is the reason and this is the answer. Because the object with higher temperature have higher kinetic energy. What must be true of two objects? If the objects are in a state of equilibrium, the temperature is the same. A state of equilibrium for two substances, their temperatures are the same. Their temperatures are the same, okay? So we recall existence of the different scales of measuring temperature, Celsius, Fahrenheit, and Kelvin. To convert temperature reading for the one scale to another, use this table, okay? Guys, this table is very important to convert between the scales of the temperature. like convert Kelvin to Celsius. Kelvin to Celsius, T Celsius is equal to what? T Kelvin minus 273. It's very easy. Sometimes you have to convert Kelvin to Celsius. How can you convert Kelvin to Celsius? T Celsius is equal to T Kelvin must be given minus 273. For example, convert 0 Celsius to Kelvin. Kelvin is equal to what? This is convert Celsius to Kelvin, like in the second case. Convert Celsius to Kelvin, you have to add them, okay? Convert Celsius to Kelvin. T Kelvin is equal to T Celsius plus 273. Like 0 Celsius to Kelvin is equal to what? 273 Kelvin, okay? 0 Kelvin is equal to how many Celsius? Negative 273 Celsius. T Celsius to Fahrenheit, how can you convert Celsius to Fahrenheit? T Fahrenheit is equal to 1.8 T Celsius plus 32. Convert T Fahrenheit to Celsius. T Celsius is equal to T Fahrenheit minus 32 divided by 1.8. Kelvin to Fahrenheit, we don't have directly equation to convert Fahrenheit to Kelvin. How can you convert Fahrenheit to Kelvin? T Kelvin is equal to, you have to convert T Kelvin to Celsius, after that Celsius to Fahrenheit. Guys, once again, listen carefully. How can you convert Kelvin to Fahrenheit? Okay, Kelvin to Fahrenheit. At first, you have to convert Kelvin to Celsius like this. After that, you have to convert this Celsius to Fahrenheit by using this equation. For the last one also, you have to do the same thing. It's very easy, just replace. Another topic is heat and energy. So we studied everything about the temperature and the scales of the temperature and how can you convert and how energy transfer between the object because of different in temperature. What is heat? Heat is completely different with the temperature. Heat, the energy transfer. What is heat? Is the energy transfer between objects because of difference in their temperatures. When does we have energy transfer between two objects? If the temperature of the two objects are different, okay? But if the two objects, they have the same temperature, we don't have energy transfer. Energy transfer exists only between the two objects with the different temperatures, okay? Heat can be understood in two ways, like thermal energy and energy transfers. Thermal energy, in scientific context, heat refers to the total thermal energy. What is heat? Is the energy, total thermal energy of a substance. This energy is related to the motion of the atoms and molecules within the substance. The faster the atoms and molecules move, has more kinetic energy, the hotter the substance is considered to be. When does the substance considered to be hotter? If the atoms are moving faster, okay, and its temperature also increases. Energy transfer, more commonly heat is referred to as the transfer thermal energy between the object with different temperature. With what different in temperature? Heat always flows from a hotter object, higher temperature, to colder object, lower temperature. This transfer continues until thermal equilibrium is reached. At thermal equilibrium, we don't have any more energy transfer. How energy in the form of heat transfer between objects? From higher temperature to the lower temperature. Moves from object higher temperature to the lower temperature. Energy is transferred as heat. As you can see in this figure, we studied that the energy is transferred from the drink to the can by molecules in the drink collide with the metal atoms of the cup. The atoms vibrate more because of their increasing of the energy. And this energy is transferred to the surrounding water molecules, and the energy transfer will exist between these two substances. Heat transfer and change in temperature. Thermal equilibrium may be understood in terms of energy exchange. Thermal equilibrium exists by energy exchange after they reach the same temperature between two objects at equal temperature. When the can of the soft drink and the surrounding water are at the same temperature, the quantity of the energy transfer from the can of the soft drink water is the same as the energy transfer from the water to the can of the drink. So the net energy transfer between them becomes what? Becomes zero. As you can see in this figure, how many substances do we have? Two. Can and the water. Both of them, they have the same temperature. Energy transfer out of the can into the water, and the energy transfer into the can from the water until they reaches the thermal equilibrium. At thermal equilibrium, net energy exchange between two objects is equal to what? 0. Okay? Another definition, guys, look, internal energy, U. What is internal energy? Internal energy, the energy of matter due to the random motion of its molecules. It is the total energy of the molecules or of these molecules. What is internal energy? The energy of matter due to what? The random motion of what? Of molecules. It is the total energy of these molecules. What does the energy transfer as heat between two objects because of difference in temperature depend on? When does we have more energy transfer between two objects and when does we have less energy transfer? It depends on the difference in temperature. When we have more difference in temperature, we have more energy transfer. Less energy difference temperature, less energy transfer. Look at these two examples. For example, a piece of metal with the temperature like 100 Celsius, a bucket of water, a beaker of water. The temperature of water, for example, is 20 Celsius. Okay? In a physical contact, if you put the metal into the water, the energy will be transferred from the higher temperature to the lower temperature until it reaches the thermal equilibrium. What is the difference in temperature? Difference in temperature between these two substances, 100 minus 20. 100 minus 20. Delta T is equal to what? 80 Celsius. Difference in temperature in this case is equal to 80 Celsius. Another example, situation number 1 and 2. If a metal, 80 Celsius, a bucket of water, for example, 30 Celsius. Okay, 30 Celsius. Do we have energy transfer after put the metal into the water in a physical contact? Yes, absolutely, because difference in temperature. What is the value of difference in temperature? 80 minus 30. 80 minus 30 is equal to what? 50 Celsius. So delta T is equal to what in the second case? 50 Celsius. Which one has more delta T? Which one has more difference in temperature? Absolutely the first case. Of course, the first case, number 1 has more difference temperature. So because it has more difference in temperature, also has more energy transfer. This one has more energy transfer compared with the second case. Okay? So the energy transfer depends on difference in temperature. What does energy transfer as heat between two substances because of difference temperature depend on? Energy transfer depends on the difference of the temperature of the two objects. The greater the temperature difference between two objects, the greater the amount of the energy that is transferred between them as heat. Look at these two figures, figure A and figure B. Which one has more energy transfers and why? So you have to pay close attention for the temperatures, for the temperature for each substance. In the first case, figure A, we have the temperature of the raindrop, 5 Celsius. Figure A. Temperature of the raindrop is equal to 5 Celsius. The temperature of the surface of car is 30 Celsius. 5 Celsius and 30 Celsius. Do we have energy transfer between these two substances? Of course, yeah. What is the difference in temperature here? The difference in temperature for the configuration number 1, the figure number 1, delta T is equal to 30 minus 5. Delta T is equal to 25 Celsius. Okay, the first case difference in temperature is 25 Celsius. For the second case, look, temperature of the raindrop, figure B, the temperature of the raindrop is 20 Celsius. And the temperature of the surface of the car is 45 Celsius. What is the difference in temperature in this case? Difference in temperature is equal to 45 minus 20. Delta T is equal to 25 Celsius. So you have to compare with the first case. Which one has more change in temperature or difference in temperature? Both are the same. Both, they have the same difference in temperature, so that is why they have the same energy transfer. There will be no difference between the energy transfer in figure A and figure B. Both of them, they have the same temperature difference, and they have the same energy transfer. The energy transfer each second as heat from the car surface to the raindrop is the same. Energy transfer is the same for low temperature A as for high temperature, provided the temperature difference are the same. Because the temperature difference are the same, that is why they have the same energy transfer. The units of heat, just other forms of energy, have a symbol that identifies them. PE for potential energy, KE for kinetic energy, U for internal energy, work, W for work, and is indicated by the symbol of Q. The symbol of the energy, like we have potential energy, kinetic energy, work, internal energy, and also the symbol of the work is the symbol of the heat is Q, also measured in joules. As the unit of the heat is joules, which is equal to kilogram meters square per second square. Based on this equation, guys, look, gravitational potential energy is equal to what? mgh. All types of energy measured in what? Joules. What is the equivalent unit of joules? All types of energy, including potential energy, kinetic energy, internal energy, the amount of energy as heat, all of them measured in what? Joules. What is the equivalent unit of joules? Based on this equation, mass measured in what? Kilogram. Gravity, meter per second square. Height, meter. Meter times meter, meter square. It's gonna be what? Meter square. What is the equivalent unit of joules? Kilogram meter square per second square. So this is very important. Pay close attention, please. And calorie also can be used for the measuring energy, but usually we are using joules. Okay, 1 calorie is equal to 4.186 joules. We will study in detail, inshallah, in section 2. Kilocalorie is equal to 4,186 joules. Dietary calorie, we have, this is the prefix is not very important, okay? But the first one is very important. Pay close attention, please. Okay, what is the equivalent unit of joules? Kilogram meters. 120 calories is equal to how many joules? Multiply by 1.486. Heat and work. As you can see in this figure, there will be a mutual function between heat and work. Hammer a nail into a block of wood, okay? After several minutes, pray and take out the nail loose from the block and touch the side of the nail. It feels what? Warm. Why? Because work is converted into what? Converted to the thermal because of the friction. Work converted, transferred into the thermal energy to touch, indicating that the energy is being transferred from the nail into your hand, okay? Because when you touch the nail, you feel warm, and the temperature of the nail increases because the work is converted into the thermal energy because of the friction. And when you touch the nail, you can feel this hotness, this warmness of the nail, because the energy transfer from the nail to your body because of difference in temperature, okay? And energy being transferred from nail to your hand. Work is done, is pulling the nail out of the wood. This increase in the internal energy of the nail rises the nail's temperature, and the temperature difference between the nail and your hand results in the transfer of energy to your hand as heat. What is friction? Is just one way of increasing the substance's internal energy. How can we increase internal energy? By friction. By what? Friction. And also by deforming. Is the case of the solid's internal energy can be increased by what? Deforming. What are the ways to increase the internal energy? Friction and bending. Okay? In how many ways we can increase the internal energy? By friction or by deforming or bending. Okay? By friction or deforming structures such as a metal, bend or stretched. Conservation of total energy. What is the conservation of total energy? The total energy can never be destroyed, can never be created, but it can change from one form to another form. When the concept of mechanical energy was discussed, you discovered that whenever friction between two objects exists, not all of work done in overcoming friction appears as a mechanical energy because some of the energy is converted to the thermal energy. Not all of the kinetic energy is inelastic. Collisions remain as a kinetic energy. Some of this energy absorbed by what? Object as internal energy. In a mechanical energy, for example, when a child slides on a slider, not all the potential energy converted into the kinetic energy. Some of this potential energy is converted into the thermal energy, okay, because of the friction between the child and the slides, okay? So in this case, in this section, we are focusing on the internal energy. The amount of the internal energy increases by potential energy or by kinetic energy. What is the law of conservation of total energy? This is very important. The law of conservation of total energy. The law of conservation of total energy. So this is very important. Energy can neither be created nor destroyed, but only transform it from one form to another form. So mathematically, you can write this: change in potential energy plus change in kinetic energy plus change in internal energy is equal to what? 0. This is a mathematical representation of the conservation of total energy. What is this? This is the conservation of total energy. Energy can never be destroyed, can never be created, but only transfer from one form to another form. Guys, what do you mean by this delta? Delta, it means final minus initial. For example, delta PE, it means that PE final minus PE initial. Final potential energy minus initial potential energy. Plus delta KE. KE final kinetic energy minus initial kinetic energy. Plus final internal energy minus initial internal energy is equal to 0. The second equation, just analyze it. We open the delta, final minus initial. The third step, you can rearrange this equation. You can transfer this negative to the other side. What does remain here? Only the final quantities remain in the left side, and the initial quantities goes to the right side. What does remain here? Final potential energy plus final kinetic energy plus final internal energy is equal to other side. This negative, it becomes positive when you transfer to other side after equal. It's gonna be initial potential energy plus initial kinetic energy plus initial internal energy. So what is this? This is also the conservation of total energy, okay? The final total energy is equal to initial total energy. Energy can neither be created nor destroyed, okay? So the equation of potential energy, keep in your mind, this is very important. Gravitational potential energy is equal to what? mgh. What does gravitational potential energy depend on? Mass, gravity, height. The energy of an object associated with the position does not depending on the movement. For example, if the object placed at the table, does the object have potential energy? Yes, gravitational potential energy. Why? Because the object has mass, height, and already it has gravity. Kinetic energy associated with the motion of the object is equal to 1/2 mv squared. For stationary object, when the object is at rest, can we say this object has kinetic energy? No. Why? Because the object at rest, no movement. Whenever the object is in motion, it has kinetic energy. Every object is in motion has kinetic energy. The kinetic energy of the moving object is equal to 1/2 mv squared. Depend on mass and the square velocity. If half of the object's kinetic energy is converted into internal energy, you have to use this relation. This is very important, guys. Be careful. If half of the object is kinetic energy, what do you mean? What do you mean by half of object is kinetic energy? Half, it means that 1/2. Half of what? Of object is kinetic energy. Half of kinetic energy is converted to what? Internal energy. It means delta U is equal to half of its kinetic energy. If 1/3 of object's kinetic energy is converted into internal energy, delta U is equal to what? 1/3 of kinetic energy. Okay? If 3/4 of the object's kinetic energy convert into internal, 3/4, 3/4 kinetic energy converted into the internal energy. For the potential energy, we have the same thing. If 65% of potential energy, look, 65% of potential energy convert into what? Internal energy. It means that delta U, 65% is equal to what? 65/100. 0.65 potential energy. 75, 0.75 gravitational potential energy, and so on. Look at sample problem 4A. Listen carefully, very easy question, very easy sample problem, but many students are struggling with this question and they have a bad time with this question. Listen carefully and I'm going to explain in the easiest way. An arrangement similar to the one used to demonstrate energy conservation is shown at below here, as you can see in this figure. A vessel contains water. A vessel contains what? Contains water. Petals that are propelled by falling masses turn in the water. This agitation warms the water and increases internal energy. When the mass falls down, this agitation in turn rotating and it goes to increasing internal energy. The temperature of the water is then measured, giving an indication of the water's internal energy increases. If total mass is equal to what? Mass for both objects is equal to 11.5 kilogram. 11.5 kilogram. Falls 1.5 meter. Falls height is equal to what? 1.3. Sorry. Height is equal to what? 1.3 meter. The two masses are falling from this height. And all of the mechanical energy is converted into internal energy. When the question says all mechanical energy, it means that kinetic energy initial is 0, kinetic energy final also 0. How much will the internal energy of the water increases? When the two masses are falling down, when they falls to the ground, P final becomes what? 0. Why? Because when the two masses are falling downward on the ground, we don't have height. So that is why PE final also equal to 0. So what is unknown? We have to find how much will the internal energy of the water increases. Internal energy increases, it means that delta U, what is unknown? Delta U is unknown. Look, delta U is unknown. Guys, look, according the total conservation of total energy, P final plus kinetic energy final plus internal energy final is equal to PE initial plus KE initial plus U initial. Okay? So PE final is equal to what? 0. Why? Because the objects are falling downward into the ground. Kinetic energy 0. Final unknown. Initial potential energy, can we say initial potential energy is 0? No. Why? Because initially the objects have gravitational potential energy. Why? Because we had height at first. Before falling the two masses, they have gravitational potential energy. Why? Because they have a height. Okay, how can we determine gravitational potential energy? Mass times gravity times height plus initial kinetic energy also 0. Yes, initial internal energy. If you rearrange, take this plus positive initial internal energy, transfer it to the other side, it's gonna be what? Minus final internal energy minus initial internal energy is equal to what is remain in the right side? mgh. U final minus U initial isn't equal to delta U. Yes. Mass 11.5. Gravity 9.181. Height 1.3. Delta U is equal to what by your calculator? I think is equal to, let's calculate. 11.5 times 9.81 times 1.3. I got 146.7 or 147 joules. This is the increasing of internal energy of the sample problem for A. Very easy question, and in this way you can find change in internal energy. Question 1, practice 4A. Practice 4A. Question 1. In the arrangement described in a sample problem, so you have to do the same thing. Question 1 related with the question 2. I'm not going to solve, okay? So you can solve by yourself. It's very easy. Only instead of 1.3, you can write down what? 6.69. So the difference between the question, the sample problem and question 1, instead of this 1.3, write down what? 6.69. Okay? So delta U is equal to what? Also mgh. Mass is the same, 11.5. Gravity is still the same. But instead of 1.3, write down what? 6.69. So you will get the answer. Okay? Question 2. Question 2. A worker drives a 0.5 kilogram spike into a rail tie with a 2.5 kilogram sledgehammer. What is this? This is the mass of hammer. Mass of spike is equal to what? 0.5. So mass of hammer is equal to what? 2.5 kilogram. The hammer hits the spike with the speed, the hammer. V of the hammer is equal to what? 65 meters per second. This is the hammer speed. If 1/3, guys, pay close attention, please. 1/3, what do you mean by 1/3? 1/3. This is 1/3. 1/3 of what? Hammer or spike? Hammer. So that is why we don't need this spike. The hammer's kinetic energy converted into internal energy. 1/3 of hammer's kinetic energy convert to what? Internal energy. Okay? This information was given in the question. So this is very important. Pay close attention, please. 1/3 of hammer's kinetic energy, not spikes. That is why we don't need this spike. Convert into what? Internal energy. Okay? How much does the internal energy increases? Delta U is unknown. What is unknown? Delta U is unknown. Now replace 1/3 times the equation of hammer's kinetic energy is equal to what? 1/2 mv square. Which mass of hammer? Speed of hammer. Delta U is equal to 1/3 times 1/2 times 2.5 times 65 square. Delta U is equal to what? At first, open the square, 65 square times 2.5 times 0.5 times 1 divided by 3. I got 1,760 joules. Okay? 1,760 joules. 1,760 joules. Okay? This is question 2. Question 3. Look at question 3, guys. 3 times 10 to the power negative 3 kilogram copper penny. So this is mass. Mass of the copper penny was given. 3 times 10 to the power negative 3 kilogram. Drops at a distance. When the object drops, it means that falls. Okay, so it means that this object has height. What is the distance of the drop? It means height. Height is equal to what? 50 meters to the ground, above the ground. Okay, if 65%, what do you mean by 65%? It means that 65 over 100. 65% of what? Initial potential energy. Initial potential energy. Because final potential energy is 0. Why? Because the object falls down at final. Finally, the object is at the ground and we don't have height. Goes into what? Internal energy. Increasing the internal energy. Goes into what? Increasing internal energy. What is unknown? Determine the magnitude of that increases. It is very easy. Delta U 65 over 100, 0.65 times potential energy is equal to what? AmGh. 0.65 times 3 times 10 to the power negative 3 times 9.81 times 50. So delta U is equal to what? Delta U is equal to 0.96 joules. This is the increasing of the internal energy. Question 4. The amount of internal energy needed to rise the temperature of 0.25 kilogram of water by 0.2 Celsius. The amount of what? Internal energy, delta U, for increasing 0.25 kilogram of water by 0.2 Celsius is equal to what? 209.3. Question 4. Delta U is equal to what? 209.4 joules. 0.3, sorry. Okay. How fast? So in this question, we have two different examples, two different things. How fast? What do you mean by how fast? V is unknown. V for what? 0.25 kilogram baseball. So V baseball is unknown. When mass of the baseball is equal to 0.25, okay? Travel in order for what? It is kinetic energy. The kinetic energy of bowling ball. What do you mean by it is? It means the kinetic energy of the bowling ball is equal this internal energy. Kinetic energy of the bowling ball is equal to what? Internal energy, which is equal to 209.3 joules. Okay, it's very easy. Kinetic energy of the bowling ball is equal to 1 over 2 mv squared. 1 times mv squared over 2. Okay? Cross product. 1 times mv squared, mv squared. 2 times kinetic energy, 2 kinetic energy. What is unknown? V. V squared is equal to what? 2 times kinetic energy over mass. Take the square root for both sides in order to remove the square, because the question asks us to find speed, not square speed. Take the square root. So V is equal to what? Radical 2 times kinetic energy of ball over mass. Look. V is equal to what? 2 times kinetic energy was given indirectly, 209.3 divided by 0.25. V is equal to what? 40.9 meter per second, or 41. Okay? That's all for today, guys. Hope you benefited from my lesson. Inshallah, in the next lesson, we will continue to explain the other sections and the other chapters for grade 10 students. Have a good time. Keep up your best doing. Thanks for listening.